Have you ever wondered why the moon turns a blood-red hue during a lunar eclipse? A lunar eclipse, a celestial dance between the sun, earth and moon, has been a source of awe and intrigue throughout human history. Cultures across time and geography have spun tales and myths to explain this enigmatic occurrence, often attributing it to divine intervention or ominous portents. Yet the reality is rooted in the realm of science, not superstition. It's a fascinating interplay of light, shadow, and cosmic alignment that paints the moon red. Sounds intriguing, doesn't it? Well, it's even more captivating when you delve deeper into the science behind it. So, let's embark on a captivating journey through the cosmos, dismantling age-old misconceptions and unveiling the true beauty of this lunar spectacle. Because the truth, as they say, is often stranger than fiction. So buckle up, stargazers. In the next few minutes, unravel the mystery behind this celestial spectacle. To understand lunar eclipses, first grasp the concept of the Earth's shadow. Let's dive into the science behind the shadows. Shadows are formed when an object blocks the path of light. In our case, our planet Earth plays the role of this object. When the sun's rays hit the Earth, the planet obstructs some of the rays, casting a shadow in space. Now let's add a bit more complexity to this. The shadow cast by Earth in space isn't a single uniform dark patch. Instead, it comprises two distinct parts, the umbra and the penumbra. So what are these? The umbra is the inner, darker part of the shadow where all the light from the sun is blocked by the Earth. If you were standing on the moon and looking at the sun while in the umbra, you wouldn't see the sun at all. It's like being in the middle of a pitch-black room with no windows. On the other hand, the penumbra is the outer part of the shadow where only a portion of the sunlight is blocked. It's a region of semi-darkness where some sunlight still manages to reach. If you were on the moon in the penumbra, you'd see the sun, but it would appear partially obscured. It's akin to being in a room with a dimmed light. You may be wondering, why does this matter for a lunar eclipse? Well, this shadow plays the starring role in the grand show of a lunar eclipse. As the moon orbits the Earth, it occasionally passes through this shadow. When the moon enters the umbra, we get to witness a total lunar eclipse, with the moon appearing to darken completely. But when the moon is in the penumbra, a partial lunar eclipse occurs, and we see only a portion of the moon darken. So in essence, the science behind a lunar eclipse is a fascinating interplay of light, shadows, and celestial alignments. The shadow that our planet casts in space sets the stage for one of the most captivating spectacles in the night sky. As the moon orbits the Earth, it occasionally passes through this shadow, leading to a lunar eclipse. Picture the moon embarking on a journey through the Earth's shadow. This celestial voyage is a multi-stage process, each with its own unique characteristics and visual splendor. The journey begins with the penumbral phase. During this stage, the moon slowly enters the outer edge of Earth's shadow, known as the penumbra. It's a subtle shift, often unnoticed by the casual observer. The moon's brightness dims ever so slightly, as if a translucent veil is drawn over its face. As the moon continues on its path, it moves deeper into Earth's shadow, heralding the onset of the partial phase. This is when things start to get truly dramatic. A dark curved shadow begins to creep across the moon's surface, creating a stark contrast between the illuminated and the shadowed parts. It's as if someone is slowly taking a bite out of the moon, one tiny nibble at a time. Finally, the moon enters the total phase, the climax of this celestial performance. Completely immersed in Earth's umbra, the darkest part of the shadow, the moon dons a completely new avatar. But rather than disappearing into the darkness, it gets bathed in an eerie, blood-red glow. This transformation is not a trick of light nor a cosmic illusion, but the result of Earth's atmosphere. Our atmosphere refracts or bends the sunlight, filtering out all colors except red. This refracted light then reaches the moon, casting a crimson hue over it. It's the same process that paints our skies with vibrant reds and oranges during sunrise and sunset, only in this case it's happening nearly 240,000 miles away on the moon's surface. So the moon's journey through Earth's shadow is not just a celestial event, but a celestial spectacle, each stage offering a unique visual treat. It's a dance of shadows and light, a testament to the intricate dynamics of our universe. So the eerie, blood-red color of the moon during a total lunar eclipse is actually a result of our own atmosphere. Now that you know the science behind lunar eclipses, let's debunk some popular myths. There's a fascinating array of tales and superstitions surrounding lunar eclipses, but they're just that, stories. One such myth is that lunar eclipses are bad omens, bringing forth disaster or ill fortune. Science, however, tells us a different story. Lunar eclipses are simply the result of the Earth's shadow cast on the moon, and they bear no impact on our day-to-day lives. Another common belief is that lunar eclipses can affect human behavior or health. Again, there's no scientific proof to back up this claim. Lunar eclipses are natural phenomena with no direct impact on our physical or mental well-being. You may have heard that food spoils during a lunar eclipse. Yet again, this is a misconception. The duration of a lunar eclipse is too short to have any substantial effect on food safety or quality. Remember, science often has straightforward answers to what might seem like complex phenomena. So, what have we learned about lunar eclipses today? We've unraveled the enigma of lunar eclipses, understanding that they're not just celestial phenomena, but a cosmic ballet of sorts. We've discovered how Earth's shadow plays a crucial role, casting a dark veil over the moon's surface, creating this spectacle. We've journeyed with the moon through its stages during an eclipse. We've learned about the penumbral stage, where the moon first touches Earth's outer shadow, the partial stage as the moon begins to darken, and the total stage when the moon is fully immersed in Earth's umbra. Perhaps most fascinating is the moon's dramatic change in color during a total eclipse. We've learned that this is due to Rayleigh scattering, the same process that gives our sky its blue color. But when it comes to the moon, it paints it a vibrant shade of red. The next time you witness a lunar eclipse, you'll know exactly what's happening up there in the night sky.